Okay, today we're going to be looking at trigonometric ratios of general angles. So let us just have a wee recap. So we have our axes x and y, and say we have some point P, and it has ratio r, and P has the coordinates x and y. Now, come down here, this is right angle, and that's length y, and this is angle theta, and this is length x. So we've got a nice right angle triangle. Now if we consider this as a circle round the axes, we can get our general trigonometric identities. So sine theta is going to be y over r, cosine theta is going to be x over r, and tan theta is going to be y over x, where x is not equal to 0. So x and y are our coordinates, and r is our hypotenuse of this right angle triangle, but it's also the radius of our circle. And we can find r through Pythagoras of x squared plus y squared, the square root of that. Now, from this, I'm going to leave those up, and from this we get an interesting result. If we were to look at the values of sine theta, cosine theta and tan theta, and consider when are they positive. So let's draw a coordinate grid with our quadrants. So we have 0, we have 90, we have 180, and we have 270, and then it comes back here to 360 degrees. Now, in our first quadrant, all the identities, sine theta, cosine theta and tan theta, they're all positive. In our second quadrant, only the ratio of sine is positive. In our third quadrant, only tan is positive, and in our final quadrant, only cosine is positive. And this is something you need to memorise, and we can use the little mnemonic, all students trust Cambridge. ASTC, and that reminds us what quadrants the ratios are positive in. And we can use this to help us answer some questions. So let's first, I'm going to leave these up here. I'm going to leave our identities up here because that's going to be useful. So we're going to express sine of 140 as a trigonometric ratio of acute angles. So remembering back, an acute angle is one that is less than 90 degrees. So let's think about our sine of 140. So that's 180. So 140 is going to be over here somewhere. Because greater than 90, but less than 180. So that's about 140. And so in this quadrant, sine is positive. So this here, if that's 180, this angle here must be 40. So sine of 140 must be equal to the sine of 40, because that's the same angle as that. We're going to express the cosine of minus 130 degrees in the same way as a trigonometric ratio of acute angle. Of an acute angle. So again, let's think about what this means. So previously we said that if the angle goes in an anti-clockwise direction, it's positive, but if an angle goes in a clockwise position, in a clockwise direction, it's negative. So this is a negative angle. And so this must be coming down this way. It's greater than 90, so it come down to about here. Oh, that's a terrible straight line. Oh, sorry. So this is our 130 degrees, and to make it, to complete from a, if we take 180 minus 130, we're going to get 50 degrees. And from previously, this is our, if we think about all students trust Cambridge, well, in this quadrant, in the third quadrant, tan is positive, but we're dealing with cosine, so it must be negative. So cosine of minus 130 degrees must be the same as minus cosine 50 degrees, because this angle is coming in the positive direction here. We're going to look at another one. So we're given the cosine of theta equals minus 3 over 5. And that 180 degrees is less than or equal to theta, less than or equal to 270 degrees. Find sine theta and tan theta. So let's draw our quadrant again, and add in, all students trust Cambridge. And we know from here, this tells us what quadrant we're dealing with. So theta is between 180 and 270. So we're in the third quadrant where tan is positive, but as we can see, the cosine is negative. Now what do these numbers here mean? Well, if we look here, this 3 is the x coordinate, so we've got an x, this is 3, and the 5 is the radius, so that'll be 5. Well, it'll be minus 3 because it's negative. So we have this right angle triangle of 3 and 5. So we can use Pythagoras to find what the y coordinate would be. So the y-coordinate would be equal to 5 squared minus minus 3 squared, which is going to be 16. So y equals 4. But since that, if you look at this here, it's a negative, it's going to be, well, but y can be plus or minus 4 because it's the square root. So y will be equal to minus 4 because it's coming down into this quadrant. So we can now work out sine theta is going to be equal to minus 4 over 5. And tan theta could be minus 4 over minus 3, which is 4 over 3. And that's positive, which we would expect. So now this is without a calculator. Find exact values of the sine of 120 and the cosine of 7 pi over 6. So, we'll draw a wee diagram for our quadrants again, and the sine of 120, so that's going to be over here again. So that'll be 120 degrees. And that means this must be 60 degrees. Because 180 minus 120 is 60. Therefore, the sine of 120, now remember, all students trust Cambridge, this is in this quadrant, so the sine's positive, must be equal to sine of 60 degrees, but we've already memorised that as being root 3 over 2. Remember, that's one of these identities that is really useful just to have locked away in there to pull out, because it's one that we will keep coming back to. So let's think of this next one. So again, we'll draw a wee diagram. So 7 pi over 6 is in the third quadrant. So it'll be round about here. So that's 7 pi over 6. And this is in the t quadrant, so tan is positive, so cosine is going to be negative. Now, what is this angle here? So if we do 7 pi over 6 minus pi, we're going to get pi over 6. And that therefore means that cosine of 7 pi over 6 must be equal to minus cosine pi over 6. Now again, we know what this is. It's minus root 3 over 2. Let's look at just a few more wee examples that are going to build on each other. So we're given the sine of 50 degrees equals some value b, and we want to express the following in terms of b. So first we want to express the sine of 230, the cosine of 50, the tangent of 40, and the tan of 140. So let's look at the first one to begin with. Let's think about where this is. So 230 degrees will be over here somewhere. So that will be 230 degrees. Well, what's this angle in here? So 230 minus 180 equals 50. So this is 50 degrees. Therefore, the sine of 230 must be equal to the sine of 50, minus 50, because remember, all students trust Cambridge, and that's t, so the sine is going to be negative, so it must be minus the sine of 50, which must be equal to minus b. Now for the next one, let's think about this, cosine of 50. So we're going to draw a right angled triangle. And if this is 50, well, let's think about the sine. The sine of the angle is the y coordinate over r. So if we make the y coordinate here the opposite, b, because it's going to be b, and then divide that by 1, we get b. And then we can use Pythagoras to give us this part down here. So that would be 1 minus b squared would give us this line here. So the cosine of 50 must be equal to the 1 minus root of b, 1 minus b squared square rooted over 1, which is square root of 1 minus b squared into the square root. Likewise, if we use the same triangle, the tangent of 40, well, let's think about our triangle. This is 90, this is 50. This angle here must be 40 degrees. So our tangent must be 1 minus b squared square rooted all over b. Now let's think of the tan of 140. So 140 is over here. It's 140. And we've got our ASTC. Now 140, what's that? What's this angle in here? 180 minus 140 will give us 40. Now we already know the tan of 40, so the tan of 140 must be equal to, now look, in this quadrant the tangent's negative, so it must be minus the tan of 40, which equals minus what we've just worked out here, 1 minus b squared over b. So I hope that helps.